I'm Russ Garcia, CEO of Menlo Micro Systems. We're here at PCIM. We want to show you a couple of demonstrations of our ideal switch in a circuit breaker application. To go through this demo, I'd like to introduce our Vice President of Engineering, Chris Umminger. Chris?
Hello. So what we're showing in this demo is a comparison of the ideal switch technology in a form factor that you would see in a DIN circuit breaker. And we're comparing the MEMS technology against a state-of-the-art silicon, in this case a silicon carbide JFET. So what we have here is the form factor, the number of devices that you could put into a DIN circuit breaker for both silicon carbide and for the MEMS ideal switch. And over here, we're showing those two arrays with 40 amps flowing through them. Now for the MEMS array, you have an effective resistance of about 1.4 milliohms. And for the silicon carbide array, because of the higher resistance of that technology, the total resistance in that form factor is about 4.2 milliohms. So roughly a factor of 3 higher. So for each of these arrays, we have 40 amps flowing. And we have thermal cameras above monitoring the temperature. So the additional power dissipation in the silicon carbide array leads to about a 90 degrees C temperature rise versus a 30 degrees C rise for the MEMS technology. So roughly a factor of 3 increase in temperature because there's a factor of 3 increase in heat loss and power dissipation.
So for the second demonstration, what we'd like to do is show you what that means in a real application. So Chris, you want to show the 100 amp Navy application?
So in this board, we're showing the first step on the path to do this 10 megawatt, 1000 volt, 10,000 amp circuit breaker that we're developing in partnership with the US government and the Navy. And this first stage, we're using a 12 in parallel, 2 in series, 24 device array with 100 amps flowing through on an aluminum plate. And the intent here is to show that the current is well distributed or ballasted across all of these switches and across all of the packages. So the thermal cameras in this case are looking at both sides of the array. And as you can see, we have roughly a 30 degrees C rise. So that demonstrates the high conductivity of the MEMS switches. And they all matched within a degree Celsius, which shows that the current is well ballasted or well shared across the entire device array.